Bon dia, buenos dias, good morning to all of you, and welcome to this beautiful winter day we have in Valencia. I will try to be very short, and I will start by saying my name is Vicent Lladó. I'm the board service representative for Konecranes in the Mediterranean area, and I will take advantage of your time just to make a short introduction of my company. Well, we will be talking also a little bit about the company and most important about the NOATUM project we have been involved. Okay, my company at a glance, very short, around 12,000 employees around the world. I'm just challenging my site just to see what's on there, so please forgive me if I say something wrong. But I will say, as the most important thing, we are in around 50 countries and around 4,000 remote connections to our cranes for service purposes and more than 400,000 cranes under service contracts. This is our presence around the map. We are proud to be a global company with local spirit all the time. We are in 5 different continents, and from here, from Valencia, we are taking care of all our Mediterranean customers in all countries in this region. As you see, our headquarters are in Finland, so we are a Finnish company, and these are a small sample of our products and services. Many different lifting devices, especially port cranes. And these are the customers we are serving. As you can see, many different industries and also container handling terminals, which is the case who led us here. Well, that was short, right? Let's go to the real interesting thing today, which was our participation in the NOATUM Container Terminal Valencia project. I will tell you the whole history. We started first considering different energy alternatives for RTGs. There are 4 options, 4 standards that Konecranes is offering right now to the market. The hybrid engine, the full saving system, cable reel electrification, and also the bus bar electrification. Let's have a look to every one of them very shortly. The hybrid engine is a diesel-electric hybrid RTG, same engine or very similar engine to those you can find in hybrid vehicles, hybrid cars. And whenever it's possible, the crane is operating with electrical power drawn from the batteries. It's, as I say, it's like an hybrid car. In this case, theoretically, we are talking about a full reduction of 60%, which sounds quite interesting in the papers, but the awful truth is that it's not clear what's the lifetime of the batteries. So it can be that with the state-of-the-art technology, you can pay back this investment in 5 years, and probably in 6 years you need to buy new batteries. So to be completely transparent, this is not a clear investment as of today. But on the other hand, we have the so-called full saving system. It provides power on demand, matching the revolutions of the engine to the operation that the machine is doing. In this case, we are talking about savings around 25–30%, depending on the operation of the RTG, because this will only save fuel when idling, not when operating. The more it idles, the more it saves. In the third place, now we go fully electric. First with cable reel. As you can see in the picture, we attach cable reel, medium or high voltage, or even low voltage, a transformer, and some auxiliary diesel generator. I will not explain some more about this because Angel already did in his presentation. I will only say that there is another option, not with cable reel, but with bus bar, which gives some more, let's say, extra investment, but allows to have extra versatility when changing blocks inside the terminal. So that was our first starting point together with Noatum. And we went to the fully electric options. We started doing the engineering pre-work so the terminal could assess and could decide which was an acceptable investment or acceptable option for them. And finally, we found that the acceptable option was none. Because in the particular case of Noatum, there were not enough movements in the indicator we managed, movements per meter. So the investment was, let's say, completely interesting. Only in one particular case, only in the case of this terminal was operating only with Fantuzzi RTGs, which are the highest consumers of fuel in this terminal. Only that case it could be interesting. As you see in the figures at your right, the payback of the investment in that case would be 5 years. In that case would be interesting, but this terminal not only has Fantuzzi RTGs, but many other different versions of RTGs. So finally this investment was discarded. Then we moved on to the following option, who was, why not, LNG RTG, the same you will see later on with the yard tractor. We tried to figure out how to do that with an RTG. And finally we found that for the time being there is no suitable engine for this equipment. Yes, it exists for tractors, it exists for trucks, but not for RTGs. On top of that, LNG needs almost double. It was almost double, Curro? 1.8 extra tank capacity. So some way we needed to install an, let's say, auxiliary tank somewhere on the RTG. We did not find the right place to install it at that time. And despite it would have been a good thermal yield option, we also discarded for safety and mostly structural reasons. And then we moved on to the final option, who was a genset modification. We changed, or we tried to change, parameters in one Fantuzzi RTG. We tried that as, let's say, the example of what could be done in the rest, to reduce power demand from the existing diesel engine. So the hoist machinery, you know, up and down, and of course the related emissions could be optimized. But that had a price. The price is that if we reduce power demand, probably we could reduce operation time. So we had to find a, let's say, a balance. We had to find an optimum if that could be done somehow. I think it's time to see a video. Some measurements were made, as you can see there, in the engine of the RTG and in the electrical components, mainly the hoist inverter of the RTG. And we tried different ways to admit power or to demand power from the engine and to measure which was the impact on the operational parameters like acceleration, like speed, etc. Finally, we found that the hoisting power demand in this particular case was around 500 kilowatts, as you can see there. Those in the left were the parameters we measured from the original configuration of the RTG. And then we saw that reducing power demand from the RTG up to 60%, we found that operation parameters or operation time was more or less the same. Differences were somewhere around 1–2%, which were operationally acceptable for the terminal and demand or power-wise were quite, or let's say, quite promising at least. Let's see another video right now. These are the tests we did with no load, with 15 tons and 39 tons, simulating full container. We measured times up and down, simulating the cycles of operation of the RTG. And for those measurements was when we found that there was no sensitive reduction of time, increase of time. So we decided to keep power demand for the RTG in 60%. You will be asking why you could not do that from the beginning. Well, it's obvious that in the time some RTGs were manufactured, there was only some diesel engines available in the market, and of course the OEMs, like we trend not to constrain yield of the RTG, but to oversize a little bit so the owner of the equipment can take the most of it. Finally, this is also a, let's say, a money comparison, which is, at the end of the day, it is the most important. And money-wise, you can see with the total cost, which is the black line, you will see that the optimum cost is also around, let's say, from 200 to 350 kilowatts, which was the same measured electrically, let's call it like that, in the RTG. So both technical-wise and money-wise, the results were comparable. And that allows the owner of the RTG to install a less powerful diesel engine, so finally fuel consumption is really less, let's say like that. So thank you very much for your attention. Now José Jiménez will finish this part of the event. Thank you.